Welcome back to our video series on bonding and molecular structure. Today we will be comparing and contrasting how ionic and covalent compounds form. Formation of ionic compounds. Here we go again. The sodium atom and the chlorine atom yield a sodium ion and a chlorine ion. This gives us sodium chloride. Notice that just because there is one electron leaving to join chlorine doesn't mean that there is only one electron within the entire structure of sodium. Remember, for valence electrons, we are only looking at the outside, the outermost electrons, okay? Valence electrons are the outermost electrons. Because these are atoms, and one donates, it completely leaves the sodium, we get ions. Sodium ion, chlorine ion. Notice that it is a +1 charge. There's no need to note that there is a 1 there, so there's only a plus. There's no need to note that there is a 1 here, so there's only one negative, okay? When you start getting in duplicates or triplets, so you get like 2 or more, you're going to start seeing numbers beside these positive and negatives, okay? Remember, to form nonpolar covalent compounds, they must be 2 of the same atom. They must be nonmetals or metalloids, okay? So 2 nonmetals or metalloids, and they can form single bonds such as in hydrogen, fluorine, chlorine, bromine, and iodine, or they can be double bonds such as in oxygen, or triple bonds such as in nitrogen. Now, the only reason that these are forming double and triple bonds here is because of the octet rule. Remember, an octet rule states that the outermost valence electrons needs to be as close to 8 as possible so that the atom can be happy. Remember, everybody wants to be a noble gas. Everybody wants to be a queen or a king in their own right. So the reason that these three bonds here, which are called a triple bond, occur, and the reason that these double bonds, such as shown in O2 or elemental oxygen, is occurring is because it gives the closest possible form of having 8 valence electrons in the outer shell. If you look at your periodic table, you'll notice that 2, 4, 6, okay? So remember, these are only 6 of the total electrons shown. Remember, there are going to be other electrons on the outside here that are not shown. So you need to count those up. Make sure that you are filling them in completely when you're going to be making some structures later. And I'll elaborate on that as we get further in class for this unit. The formation of polar covalent compounds. So one atom has a partial positive charge and one atom has a partial negative charge. This is a polar covalent bond. See that there are arrows going both ways. The notation of the arrows going both ways between these two atoms indicate that there is an equal pull, okay? But remember that there is partial negative and partial positive. So the hydrogens here are going to be partially positive, and the oxygen here is going to be partially negative. Let me see here. We're going to look at this again. So we have a partial positive, okay, on both of these guys. These are partially positive. Why are they partially positive? Well, because these are smaller. These have a smaller atomic radii than this guy. This guy this guy has a partial negative charge, okay? And he's negative because he has more power in the situation. He's a bigger atom. So remember, we've seen this figure before. It's a bonding recap for ionic and covalent. Nonpolar covalent bonds are when the bonding electrons are shared equally between two atoms. There's no charges on the atoms. Okay? These are atoms. Covalent bonds have atoms. Polar covalent bonds are bonding electrons shared unequally. So these are shared equally, these are unequally, and they're between two atoms. There are partial charges. Here we have a delta positive and a delta negative. There are partial charges that come on the two atoms, but they are still atoms. There are no charges, no partial charges on electrons shared equally between two atoms. If they are atoms, they are covalent. The difference is that polar have partial charges. Nonpolar have no charges. They're still atoms. Ionic bonds occur between ions, and this happens when an atom completely transfers an electron, which is one or more of its valence shell. Okay? These are full charges on the resulting ions. This has a complete positive or a complete negative one charge. This is a complete overall positive one charge. Notice that the electron cloud is not shared between the two. They are separated. The electron cloud is shared between the polar covalent bond and the nonpolar covalent bond. These are reactants of ionic and covalent bonding. Okay? So for ionic bonding to occur, there must be a metal plus a nonmetal. Okay? So these are two different types of atoms. Metals plus nonmetals. Okay? For covalent bonds to occur, you must have a nonmetal plus a nonmetal, or a metalloid plus a nonmetal. Okay? So there are no metals within covalent bonding. If there is a metal present, and you look at your periodic table and there's a metal, then it cannot be a covalent bond. If there is a metal present, it's going to either be a metallic bond or an ionic bond. And metallic bonds are very similar to ionic bonds, but we will discuss that later. Okay, so remember, ionic bonds, metal plus nonmetal. Covalent bonds, nonmetal plus nonmetal, or a metalloid plus a nonmetal. Okay, we have some definitions to look at here. Diatomic elements. Okay, guys, we talked about that last time and we talked about it again this time. Nonpolar covalent bonding of two atoms of the same name on the periodic table as they most naturally occur in the universe. So remember, diatomic elements occur naturally in pairs. They occur in twos, okay? They occur in sets. So di means two, atomic, diatomic, two atoms. Two atoms, okay, diatomic elements. Ionic compounds are chemical compounds comprised of ions held together by electrostatic forces. These are electric charges at rest. They are at rest because an electron has been completely transferred to another atom, okay? And what happens then is the atoms are converted into ions. Ionic compounds are from ions. They are not atoms. If they were to split, they would become ions. They are no longer atoms when they are in ionic compounds, okay? We have covalent compounds, okay? These are two or more nonmetal atoms bonded by sharing valence electrons. They can be polar or nonpolar. Remember, polar and nonpolar covalent compounds, all covalent compounds are from atoms, which are combining, okay? So if they're polar, they have partial charges on them, okay? Partial, delta positive, or delta negative charges on them. Nonpolar have no charges whatsoever. They are both still atoms. Okay. Now with ionic compounds, remember, as electric charges at rest, they get complete. They get complete charges, okay? Full-on charges. Full-on positives, full-on negatives. They're at rest because they've been transferred. So these are polar, and then you get some polars or nonpolars and covalent compounds. All right, guys, we're going to do some worksheets and some formation card times. This is going to be a group work activity, so you're going to have to separate the cards, categorize them, and draw them. Get out your colored pencils. It's time to draw.